All right. Now let's look at the last one. Let's first read the problem. I don't think I need to copy it over. It's just like five distinct lines on a located on a line, and there are 10 distances between the pair of points. Nine of them are already known here. There are if it's four choose two. I mean five choose two, right? 5 points. You choose any two of them. You got a line segment. So 5 choose 2 is 10, and now 9 of them is already known, and the other one is unknown, which is n, and it is possible that n is equal to one of them, and n is a positive whole number from 1 to 15, so everything is a whole number. That is to say every I mean smallest segment, there are four of them, they are whole numbers. That is to say we're just playing with integers in this problem throughout. Yeah, and this n guy is from 1 to 15 inclusive, and how many values of n are possible, right? That is the thing. Probably we just need to copy that number, and we don't have to copy these words. So it is 2, 3, 4, 5, 7, 9, 11, 13. So a bunch of, okay, I get that. A bunch of odd numbers and 2, 4. Okay, yeah, cool. 2, 4, 16, and then what else? A bunch of even odd numbers. Do we have 13? Wait a sec. Do we have 13? Yeah, we do have 13. 13, and then there's one that is unknown, which is n. Okay, cool. And the structure looks like this. 1.5 points. Yeah, probably 4 parts, right? And what do we do? Probably we focus on like the extremities. So the smallest guy is this guy, the largest guy is this guy. And why are they important? Okay, before that, of course, I mean, I need to mention one thing, that is, 6 is the total. Why? Because it is said in this problem that n is between 1 and 15 inclusive, right? This unknown guy. That is to say, this guy is from 1 to 15. It cannot be larger than 16. So 16 is actually the largest one. It is guaranteed to be the largest one among all these values. So it should be the total length here. So total is 16. Actually, this is a sort of a useless, but anyways, I just mark it with a color. So this is total, right? That's it. And what else? Okay, now I consider the extremities. 2 is 2 can offer some clue probably, because 2 can be split into only 1 and 1. That is to say, it cannot cover like 2 segments. Otherwise, the only possibility is 1 plus 1. And you have got only one slot for the new number. You can't have 2 of them. And not to mention 3. I mean, 3 is totally impossible. Yeah. So, I mean, 1 plus 1 plus 1 is at least 3. So every part, as we said, every part is a positive whole number. We're playing with the whole numbers here. So the point is that 2, there's a 2, so 2 can only be like one segment. It cannot be 2 segments combined or more, right? And so there are like 2 cases. Either 2 is on the end, or 2 is somewhere in the middle. That's only like 2 possibilities. The other end would be the same. I mean, due to symmetry, it doesn't matter. And I would say probably this one is not, one of them is not possible. But let's just see what happens if 2 is here. If 2 is like this, and now we should consider 13, because the rest would be 14, right? The total of rest is 14. And how do we get 13? 13, this number should appear somehow. Is it possible that, these two make 13? If these two make 13, then you need 1. Or if maybe, even if like this is 13, and this cannot be 13 because they should add to 1 and one of them will be 0. It's not possible. But what if one of them is 13? Then the rest will be 1. And look at this list. 14 is a new number and 1 is a new number. You can't have two new numbers. You've got only, again, one slot. So 13 cannot be cannot be just covered in this part. 13, if you do have some 13, it should have to do with, it is 2 plus something. It is combined. I mean, it should cover like part of a 2. So probably this is 13, or probably that is 13. You know, if this is 13, then this number is 11. If this is 13, I mean, if this part is 13, then that part is 11, right? If this is a, yeah, that's it. And what is this number? This is a 3. This is a 3. Well, now we have another problem. We have two segments here, and now this is a 3. It can only be 1 plus 2. But you've already had 2 here. You need another 2. And now you need a 1. Again, you need two new numbers, which is impossible. So you can't let this be 13. In other words, 13 is the summation of actually all 3 segments here. This is the case we are talking about. This is 13. And this is 13 and this is 3. So far so okay. So these two would make 11. So far there is no contradiction. And now let's think how we can make 11. 11. 2, 9 is not possible. 2, 9 is still possible. Probably you have additional like 2. But if you have additional 2, what will happen? For example, if you do this 2 and 9, then you have of course, I mean, if this is 2, 9, then you have an additional 2, n is 2. And then you can't have any new numbers. But do we actually have some new numbers? Yes, we do, because this gives you 14. So you also need 14. This is not okay. That is to say you need to switch them and try again. Now you have this. And what does this mean? This means you also, I mean, this is an extra 2, so n is 2. And you can't have any new numbers. However, this 2 plus 9 is another 11. No, this is 11. We've got it here. And this is another 11. Again, we can't afford having this many, new numbers. So this is also not possible. If this is 13, we can't have 2 and 9 over here. We should try something else. But this is 11 anyways. So what do? Can we make 11 another way? Yeah, probably 4 and 7 you would say. Yeah, so if we use 4 and 7, well, all of a sudden we have 7 and 3. So this is 10. 10 is a new number. So probably n is 10. But there is also 2 plus 4. That is 6. It's also a new number. This is too bad. So again, we need to switch them. 7 and 4. This means you have got an extra 7 here. So n is 7. Or maybe n is 7. But do we have actually whole new numbers? Let's see. If this is it, then look at this part. This is 14 here. Yeah, this is 14 anyways. So you already have again 14 and 7, two new numbers, which is which is what you cannot afford. Yeah, that is to say 4, 7 doesn't work either. So for this, for these two, you can't use 4, 7. You can't use 2, 9. By using 2, 9, you need to use a new number, but even that cannot save you from failure. So that is just to say this whole case is not possible. You just cannot have 2 on the end. 2 must be somewhere in the middle, right? This is the first thing I want to show you. So this is not possible, and this is for sure. Okay, this is the first message. And now let's look at 13. 13 is good because it is big enough, it is bulky, it takes up a lot of space. Wonky. Yeah. So let's say 13 takes up a lot of space. The rest would be 3. For example, can this be 13? In theory, you can have this as 13, but then the rest would be 1, 1, 1, and there are too many new numbers. Not okay. The rest is a total of 3. So can this be 13? If this is 13, the rest is just a 1 plus 2 or maybe 2 plus 1. Again, the same thing. And if you have 1 plus 2, 2, 1. First of all, 1 is a new number, but you have a 13 plus 1. That is a 14, a new number. You can't have two of them. So probably 1, 2. Again, 1 is new number, and now here 13 plus 2 is 15. No, okay, another new number, which is also not fine. So 13 cannot be something like this, right? So 13 cannot be like one segment. It's just not possible. What if 13 is somewhere in the middle? You would say, okay, what if it is in the middle? It doesn't matter. It's still 1, 1, 1. And what if 13 is somewhere like this in the middle? Is this okay? In this case, again, you will have 1 or 2 on both sides, and this would give you 14. This would give you 15, and this is a 1. There are too many new guys. This is even worse. So 13 cannot cover 1 or 2. 13 must cover 3. Total is 16. 13 must cover 3 of them, and the rest is 3. And that's the second message. Okay, this must happen. This must happen. These two things are what we want to keep in mind. So after this kind of a casework or maybe deduction, we are left with only two options. And what are they? So 2 should be somewhere in the middle, and 3 should be somewhere on the side. So it is either 3, 2, something, something, or maybe something 2, something 3. 3 on the other side, or maybe 3 on the same side. Only two possibilities, and now we're gonna discuss them. Okay, this is like the stage 1 analysis, and now the thing is narrowed down to only 2 cases. I'm gonna erase everything. Take a final look at this. And then I'm gonna erase everything, and we let it be larger. So this problem actually is just a lot of deduction, a lot of like casework. You gonna assume something, and then you arrive at some contradiction. But you start with 2 and 3 because this one cannot be broken down. This one is bulky. It takes a place. Yeah, that is why we start with these two. 3 is actually just paired with 13. Okay, so okay. By the way, maybe before that, I should mention one thing. Some of you might think this is a thing to do, like A, B, C, D. A is like the complementary of this guy, and A and B complementary of C and D, right? So first we get A and B and C, complementary of D. So we've got 3 pair of complementary values, and you look at the data set, at least you've got 16 is the total, so you've got 3 and 13, you've got 5 and 11, you've got 7 and 9. You might think that, okay, since this is the case, we've got 3 complementary pairs and they are here, so they are just these 3 in some unknown order, probably this order, or probably, I don't know, this order, in some order. These 3 are just mapped to these 3 guys. However, I would say this is wrong. If you want to start from here, this is essentially wrong. Not to mention, this is not gonna help you. Maybe you want to solve equations or something, your system of equations, but no, this is actually wrong. This is it is not guaranteed that these 3 guys are just these 3 guys. In terms of the identity, no. Why? Because you have an extra n, probably n and some guy. Maybe, I don't know. Maybe let's say 2, 4. No, n can be 12. No, 12 and 4 can be a pair. And you might ask, but we've got only like 3 complementary pairs. No, not really. Probably you have a B and a B plus C. They can be complementary. They are overlapping, yeah, but B plus C, probably 2B plus C is n plus 4, which is also 16. This can happen. That is to say, probably the identity thing is like this. It is totally mixed. We've got some other guys. It is not guaranteed that these 3 guys are just these 3 guys. There probably exist one more complementary pair. Probably not, but you never know. That is why this is the wrong way to start. If you think you can do this and solve some system of equations, no, this is the wrong thing to do. So I'm not doing this. Instead, yeah, that once came to my mind, but I realized that this is actually the wrong thing to do. So I'd rather go through the casework. Um, Now, as we said, there are two cases, right? Case one is, 2 is on the side and 3 is on the side and 2 is on the same side but towards the middle. Or 3 is on the side and 2 is on the other side, and towards the middle. Okay, then these two. Now let's do that case by case. Okay, use a different color probably. Yeah, this is what is this? This is 11, right? Okay, cool. And now what do we do? Probably we should consider, so 13 is already done. I mean, in both cases, you've got 13, so you don't have to worry about 13. The next number you need to worry about, 11 is here. For this one, I mean, for this case only, you don't even need to worry about 11. So why don't we look at the other end? Let's talk about 4. Okay, how can we get a 4? This is a 3, and 3 plus 2 is 5. So this is already either, too few or too too many. No. So 4 cannot come from here. 4 is either, containing here, one of them is 4, or maybe 2 plus 2 is a 4, like two possibilities, right? If you do a 2 plus 2, then 2 is a new number, right? And this is a 9 because the total is 11 over here. And then let's see if there's anything. If this is it, and it's 2 right here, and then what numbers do you get? You have 3, 2, 2, 9, 5, 4, 11. The three of them, that goes 7, right? And then 13, and the total is 16. So if you compare these two data sets, you notice that, yeah, that is fine. That is fine. Everything's fine. There's no contradiction. Actually, that's exactly it. So n is 2 is okay, and this is the case that works. Yeah. So we just recall this. Okay. So n is 2 with this for smallest segments being for like single segments. Simple. That's a simple. That's not single. Simple segment. They're not like compound. They're just simple. The 2, 3, 2, 2, 9, and then you've got everything. Okay. Cool. So this case is actually, okay, we've got something from the outset. And now, what if, oh no, should have used eraser, smaller, yeah. What if we just mentioned 4, right? Okay, cool. So this can probably give you a 4. What if the 4 doesn't come from here? What if the 4 is from, wait. You can't do 1, 1, so it is either this or maybe one of them is 4. If one of them is 4, if this is 4, then that is 7. Now you get a new number, which is a 6, and this is a 6. So n is 6 because 4 is not a new number. In this case, is there any like contradiction? Let's just check. N is 4. And then you've got the numbers you've got is 3, 2, 4, 7, and then 2 of them 5, 6. 6 is new. I'm sorry. This is a 6. 6 is the new number. 5, 6. This is 11. So far so okay. And then the 3 of them would be 9, right? And the 3 of them is 13. Yeah, if you compare the data sets, yeah, everything looks fine. Yeah, so this is also okay. Yeah, very good. So erase this thing. I don't need this anymore, but yeah, this is the case that can be useful to me. 3, 2, 4, 7. Good. And the 2 plus 4 is 6. This is the new number we need. What if I switch them, 7 and a 4? And now, does this actually work? This is 9. This is so is there even a new number? This is I see, this is another 11 on the other, no, this is this is a 12 actually. You get a 12 here. So is it possible that n is 12? In this case, what numbers do you get? You get 3, 2, 7, 4, so far so okay. And then you got 5, 9, 11, yeah. And then you got 12 is the new number. And then 9 plus 4, that's 13. And then if you compare these data sets, these two of them, yeah, everything works. So this is also a good, yeah, this is also a good group. And this is a, yeah, you can just switch them. So erase, probably, yeah, but that is everything actually. So that's it, right? So by considering 4, there are not many possibilities. It's either this is 4, okay, that is 4, okay, or maybe this is 4. The 3 cannot be 4, otherwise you need 1, 1, as I said. So yeah, we've got all 3 of them, and we have done the discussion with this part. And now we're gonna move to the other part. Okay, this is the 13 is done. 11 is not yet done, but why don't we still consider 4, as we know what to do, right? So how do we get 4? Probably one segment is 4, or probably 2. But let's start with one segment is 4. If this segment is 4, do you have any new number? Probably you need more than, yeah, this is a 4, then this is 9, and this is a 7, right? And now here's the problem. Here you've got 6. However, you've got another 7 by 3 plus 4. So all of a sudden you've got 2 new numbers, which is no good, right? So this is not okay. You can't just put 4 here. Then try this one, and this would be a 7. And this is a 6. So let's assume 6 is the new number. But now you've got a 10. This is also a new number. This is not okay. So 4 cannot take just one segment. It is a combination of probably 2 segments. Can it be 3 plus 1 here? Then 1 is a new number. Then no, because 1 plus 2 is just a 3. You need another 3 and a contradiction. So 4 cannot come from 3 plus 1. How about 2 plus 2? If this comes from 2 plus 2, and the 2 is put here, you already have n equal to 2. This is actually this case, right? Exactly the same. And of course, the rightmost one is 9. But this is the same case, so we don't have to discuss it. How about 2 is here? Okay, remember, I just proved that 2 cannot be here, right? If you've got a 2 on the side, then there's no way to save you from a failure. So 2 cannot be here. We don't even need to discuss it. That is to say, to get a 4, you can't use like one segment. And if you use 2 segments, this is the correct answer. You don't have to discuss the other. 1 is not okay. And what if 4 is, covering 3 segments? Then it is covering this, right? The 3 segments. Then you have 1, 1. However, both of them will be new numbers. That is not okay. So no, by considering 4, your job is also done with this part. Yeah, this is done and this done. Actually, one case is here, is overlapping with the thing here. Yeah, that's it. So that is everything. You've got 3 cases. What is asked actually? How many values of n are possible? 3 values. 2, 6, 12, 2, 6, 12, 3, C. Yeah, just a C, 3 of them. But that's all 3 cases. Yeah, that's the full discussion. Well, nothing actually fancy. Probably some people works faster, some people, work slower. Some people waste some time doing something useless. But eventually, I think everyone can find a way out. You just do this kind of a casework. But just as I said, do not make that mistake. In assuming that the 3 complementary pairs are just those 3 of them. No, that is not necessarily true. Yeah, if you don't do it that way, then you just use the idea of extremity. Consider the smallest number. What can the smallest number do? It's Not easy to make a small number because you can't cover too many segments. It's not easy to make a large number either because you don't have too many segments left over. That's it. If you start with these two things, you can, I mean, derive the final, I mean, solution, final result, no matter what. Probably you have a different way. You don't consider like 2 and 13 in the beginning. You consider something else. How can we make 3? I know how can we make 9? And I believe you still can get some result out of there. Yeah, that is it. The last problem of Gauss A, and that concludes our discussion of this year's Gauss. So yeah, see you next year.